Good morning to all. Today we are going to discuss about the Unit 1. The Unit 1 is the fundamentals of GIS. The first topic we are going to discuss about the introduction to GIS and what are the basic spatial concepts we are going to use in the GIS. So the introduction to geographical information system. The course outcome of today's topic is explain the fundamental concept of GIS. So the course outcome, it will be linked with the program outcome 1, program outcome 5. The program outcome 1 is graduate will demonstrate knowledge of mathematics, science and engineering. Graduate will demonstrate an ability to visualize and work on laboratory and multidisciplinary tasks. The course outcome, it will be integrated with the program specific outcome 1. The program specific outcome 1 is to plan, analyze and design civil structures. So a geographic information system is a system of hardware, software, data, people, organization and institutional arrangement for collecting, storing, analyzing and disseminating information about area of the earth. A geographic information system is a computer system for capturing, storing, checking and displaying data related to position on its surface. A geographic information system is a system designed to capture, store, manipulate, analyze, manage, and present all type of geographical data. The geographic information system is defined as an information system designed to work designed to work with data referenced by spatial geographical coordinates. Every object present on the earth can be geo-referenced is the fundamental key of associating any database to GIS. Georeferencing refers to the location of a layer of coverage in space defined by the coordinates reference system. In the real world, the T1 will be transferred into raw data. The raw data transfer into data model. The transformation 3, the data manipulation with the data output like an output data. That is transformation 4. So that is the entire system of geographical information system. How the real world converted into the map. So see what is a GIS. Systematically we can approach that is the information system plus the geographic position. So see the geographic position in the head we can convert it into a map. A mean of storing, retrieving, sorting and comparing the spatial data to support some analytical process. So see data like a street data, that this is a building data, that this is a vegetation data. The three data separately we have like a information. The all the data we can combine into a thematic map like integrating the each and every data like a database, that is called integrated data. So see the real world approximately we can see like that the GIS can be modeled like imagery, elevation, transportation, addresses, boundaries, water features, survey control and our data. So finally it will be converted into a different layer into a single map like a thematic map. So see this is being applied around the world. So all the places, okay. So say the resource inventories, land management, network analysis, incident mapping, spatial measurement, courier selection, the logistic routines, transportation modeling, then resource exploration, facilities management, geoprocess modeling, spread and diffusion, all the places, topographical analysis, demographic analysis, engineering design, site selection, likewise all the places it will be used on the current trend. The basic spatial concept. Basic spatial concept. A geographic information system is a system of computer application that can be used to display, manipulate, and analyze spatially varied information from multiple sources all in one place. GIS dataset can be separated into two categories: spatial or geographical information system, tabular or attributes information. So the spatial or geographical information system is the spatial data is data that is geo-referenced or location-specific shown graphically on the computer screen. Each piece of geographical information is called features, which which can be point, line or polygon. That is called like a vector data. Then table or attributes information. It is the text based or numerical information that describe each of the features. The table information is linked to the geographical information which included a unique ID number used to represent each point, line or polygon. Example of tabular data can be include such things as addresses, coordinates, area, length, sales information, road names, etc. So see the universal polygon, then spatial data, ARC function, like attributes data into 1, 2, 3, 4, 5. So information are tables function. So the 3 represented area 4, that the this is a zip number of the particular area. Types of spatial data, raster data and then vector data. So it is in the form of image such as aerial photographs or imported scan of fold maps. So the raster data stores the location and the color value of each pixel that forms the image. That vector data, the information is stored using a combination of location, specific point, lines or axes. So XY coordinates. Raster images can lose quality and become blurred when scaled. However, vector data is scalable to analyze size without losing any integrity. Representing spatial element, raster, vector, then this is the real world. So see in the raster, we are using the mapping like a grid based small pixels. Whereas in vector like point, line, polygon we are used. So that will be integrated into the real world. So representing spatial element. So see the raster. So the stores image as a rows and column of numbers with a digital value number for each cell. So units are usually represented as square grid cells that are uniform in size. So data is classified as continuous such as in an image or the thematic where each cell denotes a feature type. So the numbers, data format, TIFF, GIF, iridescent or dot image, etc. we can store. So see the representing of spatial element in vector. So allows used to specific spatial location and assume that geographic space is continuous, not broken up into discrete grid square. So we store features as set of XY coordinate pairs. So see the point, line and the polygon. The entity representation. We typically represent object in space as three distinct spatial elements: point, line, polygon. Point, simplest element; lines arc set of connect point; polygon set of connected lines. So we use these three spatial elements to represent real world features and attach locationary information to them. So the functionality of GIS, what do they do? So the GIS function: data assembly, data storage, spatial data analysis and manipulation, spatial data output. So the GIS function, so see the data assembly like manual digitizing and scanning, then manual digitizing scanning, data transfer, direct entry like a keyboard and mouse, and the data transfer in the database. So the data input are like in creation. So using the GIS software, we can given the input or we can create the data. So see the spatial data manipulation and analysis, common manipulation. So the reclassification, map projection changes, then common analysis is buffering, overlay, network. So the spatial analysis, overlay function create new layers to solve spatial problems. The spatial data output like a table, map, interactive display or 3D perspective views. So based on that, the basic introduction of the GIS and the basic spatial concept, here I have give the assessment. So once you saw the video, then kindly attend that assessment also, the full form of GIS. Then which among the following is Indian Regional Navigation System? The simplified representation of reality is called. Which among the following is or are the application of GIS? So kindly fill the option I gave. So it will give a better understanding of the GIS concept. So these are the reference material. Thank you.